Okay, gang. So what I wanted to show you in this movie here is something I didn't quite get to in class today, but it's about how is it that we integrate the ideas of the momentum theory into the computer work that we're doing. So in order to motivate this, I wanted to show you the skeleton code once again, which is what I didn't quite have on me today in class. We notice all the usual parts, part one, and we spent a lot of time in part two where the cameras, and part three where we declared initial variables and so on. Hopefully this is looking somewhat familiar to you. All quarter of this part 8 right here has been blank, this part right in here. And it says in here that part 8 deals with any abrupt changes in v. So those are abrupt changes in speed or velocity, of course. And that's exactly what we need now as we're working on our momentum. Because what the momentum theory predicts then, as we mentioned in class, is it gives us changes in speed or velocity of objects directly from the theory. We did an inelastic collision problem today in class, or whether you're doing the impulse with the two cars crashing on the track. It's the final V that we're interested in, and so that's what we also need to be interested in terms of our code. So in terms of putting momentum into all of the movies that are assigned this week, you have to look down here in part 8 now. We're not interested in the accelerations from part 5. We're not interested in feeding the physics equations directly in part 6. What we'd like is our program just to execute as normal. Take some accelerations, whatever they may be. Allow the physics equations then here in part 6 to predict the next position of the object. That's all fine. But independent of all that happening, down here in part 8, there still can be a collision or some type of interaction that's going to happen. And independent of where the physics equation thinks the object should go, part 8 should step in and abruptly change that prediction of the physics equation, say if there's a brick wall in the way, or if there's a floor in the way, or there's some reason or another object, or there's some reason why the velocity and the current direction of motion of the object needs to be changed. So all of the momentum theory, all of the movies that you'll be working on this week deal with making changes to your code down here in part 8. In other words, after the physics equations this week, not before them anymore. So remember that, part 8, after the physics equations, that's where our abrupt changes in V are going to go. So what I have to show you here is a fairly straightforward program that just launches a projectile. If I render this thing here, we'll see that the projectile just gets launched and it starts flying through the air, as you might expect. Off it goes. As it renders here, you can see the launch conditions that we're used to up here. There's initial position, there's initial angle. I think we wrote this thing a few weeks ago. But the problem with it, of course, is that when it goes in here and hits the ground, it's going to go right through the ground. There's nothing to build in that interaction between the object and the ground. We're trying to do a hard collision here. This is one of the assignments that you have. I think yours has a couple more brick walls on it, but the ideas are the same. So see, we have all the relevant physics here to get the object to fly as a projectile. We even have the acceleration in here in part 5. We've done a lot of work in this quarter, but we need to move down into part 8, which is down in here for these movies on momentum. I'll even put the comment here. Part 8 is just everything sort of between these two comments right here. Part 8, that's where the momentum stuff goes. Now, to make this object collide with the ground the way we'd want, we're going to put an if statement in the way we discussed in class. We'll say something like this. If pose.y becomes less than 0. Now I know it's going to be 0 because if I scroll down just a bit more, I have a plane here. My ground is at 0. And if the ball is either at or below 0, I know the ball is trying to get below the ground, or in either case, it's in close proximity to the ground. And I want to make some collision happen. But saying that it's near the ground isn't enough. I also have to make sure that it's going down towards the ground. So I'm going to see if vel.y is also less than 0. See if that y component of velocity is negative. So this is the condition we need here to say if the object is near the ground and it's moving towards the ground, we want a collision to happen. And I think in Pobre and is only 1 ampersand. So if this condition ever becomes true, what I'd like to do in this case, I'd just like to reverse that y component. I'm going to say declare vel is negative, vel.x, nothing happens to the x component, negative vel.y and 0, something just like that. There is that reversal of the y component of velocity right there. By putting a minus vel.y in there, I'm reversing the y component of velocity, and then I just end it. End the if statement right there. That's all I want to do. If I get near the ground here and I'm moving down here, then I want to reverse the direction of that ball. So let's render this and see what happens now. And notice where this is. This is down in part 8, after the physics equations. Let's render and see what we get. Still going, over halfway through the flight now. We should expect some interaction with the ground. Here we go. Yeah, there we go. There's the bounce right there. The y component of velocity has been successfully reversed there in part 8. So notice again the reason for part 8. The physics equations that are up here, that we all sort of know now for a while, they will tell you that the ball should keep following this parabola, keep following, keep following, keep following, and the physics equations don't know that there's a ground here. So the physics equations are just going to say, keep on going through the ground. But we know there is a ground. We have to interfere with the physics equation and say, sorry, interaction has occurred. We have an abrupt change in velocity that we want to impose on the ball. So after the equations make their prediction right here, we want to impose that abrupt change in velocity right there to get that ball to bounce back up again. That's exactly why we're working in Part 8. So the hard collision ones that you're working on, look into Part 8 to make these changes. The impulse mover you're working on, look to Part 8 for to make the changes. Same with the elastic and inelastic collisions you're doing. Look to Part 8 for all of those.